Welcome to Anderson's Water Pollution Control Facility. We'd like to give you a tour of these fascinating facilities that keep Anderson's wastewater pristine. There are two of these distillation apparatuses in Anderson's laboratory. The water must be purified through several processes to meet required standards. This meter is one of many used in the lab. The one being shown is set to indicate levels of pH to determine the acidity or alkalinity of water, a critical factor to safeguard consumers against burns to the skin. Discharge water is tested daily to ensure safety for downstream users or aquatic life. Contained in these bottles are various samples, some from the White River and some from within the treatment plant, which must be reported to state officials as well as the Environmental Protection Agency to demonstrate that Anderson's treatment processes are working properly. Ammonia makes its way into the treatment plant from various home and industrial sources. This ammonia nitrogen test is to determine that ammonia is being adequately removed from the discharge flow, also for safety purposes. This ICP, an inductively coupled plasma unit, is an instrument used to test for the presence of heavy metals in the water. It can analyze the samples for more than one metal contaminant in one process. Anderson City water is tested, as well as wastewater, river water, and industrial samples. The expense of this unit is justified in the critical procedure of ensuring that the water system is free from heavy metals. This incubator in the facility's microbiological lab is designed to maintain a constant temperature. It is utilized in monitoring city water, private drinking water, and swimming pool samples for the presence of bacteria.
Hi, I'm Webb Bernhardt. I'm with American Structure Point. We're the engineering firm that is assisting the city of Anderson with the rehabilitation of 4 of their older clarifiers here at the wastewater treatment plant. The work's going very well. We're doing them one at a time so that the plant can stay in service. We're working closely with Nara Maynor and her operational staff to maintain operations, and also with Christian Caldwell, who is the operational foreman here at Anderson. This clarifier that you can see before us happens to be number 3. A whole new mechanism was put into it. The concrete structure is old, but in good condition. For those who care, it's a very unique structure with the cantilevered beams coming out and holding the aerial effluent trough. Nice old structure, good shape. We're glad it can be salvaged and move forward. It's a good thing for Anderson that they can recoup that value. The contractor working on this job is Zachbridge Construction. They're out of Defiance, Ohio. It's their first time working here, and they're doing an excellent job for us. As you can see, we're ahead of schedule on the project, and it looks good. We dry run this device for 12 hours last night, and we're waiting now for the manufacturer's representative to tell us he's satisfied with his inspection. We're sure he is, and soon we'll be adding water to this for a wet test, followed by 5 days of operation to make sure it's operating properly before the city accepts it. When that's done, we'll move over to clarifier 4 and start the demolition and then rehab of that device in the very same way. So what is a clarifier? Clarifier is just one of the many processes that's used in the city of Anderson to purify water that's been used already in your homes. The wastewater comes to the plant through the source collection system. They use microorganisms to consume the bad things in the wastewater. Then we have what we call bugs, a collection of microorganisms in slurry with the wastewater. They come to, that mixture comes to the clarifiers. The bugs are slightly heavier than the water, and so they settle to the bottom of the clarifier, the very clean water coming right off the top, and that collection of cell bodies called biosolids are extracted through the bottom. And that's in fact what this mechanism is intended to do. It takes the microorganisms, separates them from the clear water, takes them to the bottom, takes them out where they can be recycled or disposed of.